Good morning, everyone, for joining us to review the practical steps to get started with supply chain AI. Kathy will now give you a little background on the two presenters.
Thanks, Regina. So we have Lora Cecere, CEO and founder of Supply Chain Insights, who is co-author of the book Bricks Matter and author of Metrics Matter, as well as the enterprise software blog Supply Chain Shaman. Lora has more than 30 years of diverse supply chain experience and spent 9 years as an industry analyst with Gartner Group, AMR Research, and Altimeter Group. And before that, 15 years as a leader in building supply chain software at Manugistics and Descartes Systems Group, along with several years as a supply chain practitioner at Procter & Gamble, Kraft, General Foods, Clorox, and Dreyer's Grand Ice Cream. Ram Krishnan is VP of Product Marketing at Aera Technology. He drives go-to-market strategy and execution and has more than 20 years of experience in the enterprise software industry. Prior to Aera, Ram was VP of Market Insights at Anaplan, where he led a number of strategic go-to-market initiatives. Before that, Ram was Senior Director at SAP's Analytics Center of Excellence. In his 7-year tenure at SAP, he drove product strategy and solutions for several finance and analytics portfolios. He holds an MBA in General Management and Corporate Strategy from Santa Clara University and BE in Electronics and Communication from PSG College of Technology, India. Welcome.
Well, thank you so much, Kathy, and it's great, Ram, to be able to talk to the group today about how do we get started with this exciting technology shift for cognitive computing and artificial intelligence. Today,
thank you, Laura. Pleasure to be here.
Yeah, 90% of supply chains are stuck today. If we look at, what we're able to do on the balance sheet and the delivery of the promise of supply chain excellence. And we do a lot of work at Supply Chain Insights. We've got 6 years of quantitative data, and we sit on 15 years of financial data. And one of the issues is that the supply chain is a complex nonlinear system, and it's very difficult to model a complex nonlinear system with linear applications. And so many listening may actually be driving a digital supply chain transformation, and cognitive computing and artificial intelligence may be part of the digital transformation journey. And we often find that cognitive computing is very tightly coupled with the movement to open source analytics, where we can combine relational data or transactional data with non-structured or unstructured data, and to be able to sense, listen, learn, and then respond. And we also find that, the combination of cognitive computing with blockchain is often seen where we're actually combining the master data elements to write onto the blocks or write off to the blocks, or the combination of cognitive computing with streaming data to be able to look at Internet of Things with cognitive computing. And also cognitive computing plays a very strong role in robotics, and wearables and robotics are moving together in the digital manufacturing transformation. So if you're listening to the webcast today, one of the things I want you to really think about is the difference between digitization, or making data digital, and digital transformation, which I define the digital supply chain as rethinking the atoms and electrons of the supply chain that can change through the confluence of these new technologies. And one of the technologies that's really important is cognitive computing, and how we actually transform business processes through the combination of cognitive computing with these other very powerful technologies. Now, one of the things that I hope people don't do is say, okay, I'm just going to make today's processes more efficient, because today's processes were really designed in the 1980s and the 1990s, where we did not have the capabilities of computing that we have today, and we did not have the ability to model nonlinear relationships then that we can do today. And the supply chain has become increasingly more complex and increasingly less linear. Now, when we look at the disruption and we ask clients to think holistically about the top disruptors in the 5 years and the top 3 disruptors today, we see that most people are deploying Internet of Things types of projects and data visualization. And while they're very powerful, they're not seen as disruptive as cognitive computing in combination with blockchain or software robots or drones. And so cognitive computing is very disruptive. It allows us to really address the questions that we've been wanting to address for a long time, but we were stuck in a paradigm where we could not actually get to the answers for these new questions. So as we think about this evolution, let's start with data. Data today is often thought about as reporting, thought about as an adjunct to the alphabet soup of solutions that we have, like ERP or APS or WMS or CRM or SRM, and it's seen as an extension of those applications. What I want you to do, number one, in your journey to think about cognitive computing is to think about what data should move in cloud. So the ability to have cloud-based enablement for data to go across systems. And what data should move in streams, which is often Internet of Things data, and then what data should move in pools. So the first step in this cognitive computing journey is to design a data architecture that is not constrained by traditional functional IT thinking, and then start to think about how can I add cognitive computing capability to cloud. So perhaps I am going across multiple systems, or perhaps I'm enabling value networks. How can I add capabilities to streams? Perhaps it's sense and then respond. It could be telematics data, it could be images, it could be weather data, it could be sensor data on trucks, it could be sensor data on manufacturing lines. How can I sense, learn, and then act? Whereas the traditional supply chain acted but didn't sense and didn't learn. And then how can I use cognitive computing on pools of data, which gets us to schema on read, which allows us to actually use the data structures in the data pool to be able to build hierarchies and to build relationships on an as-needed basis through cognitive computing and rules-based ontologies, and to totally transform data so that perhaps we don't need to worry about master data issues, because many of our master data issues are because of disparate data, not dirty data. The data is just different. So as we think about cognitive computing, we must start at a different place. Instead of starting with the alphabet soup that you see on the left-hand side of CRM, SRM, ERP, APS, PLM, and thinking about cognitive computing as an adjunct or an accessory to alphabet soup reporting, instead what we need to think about is a world of analytics that can go across the operating systems that we have today and really drive improvements between workforce productivity and our current systems. And not just automate what we have today, but really step back and think about how do we do this differently. So today's supply chain process thinking is limited by the fact that we want to stuff all data into rows and columns, and we want the data to be pristine and really clean before we stuff it into rows and columns. And we believe that we'll define the relationships of data early and that they'll be fixed. And as the business changes, we just have hierarchies that we know doesn't meet the current state, but it is what it is. And so as we deal with the pools of data and we move from schema on write, which has us force data into rows and columns, and fixed hierarchies to schema on read with the cognitive computing to be able to take data and to use data in its form and to let the data tell us about the process, we have a very different answer. We no longer have systems that are fixed. When we go through mergers and acquisitions, we can merge data into pools and we can start to read. This other paradigm that we really need to challenge is the system of record and linear flows. There was a misconception over the last 2 decades that we wanted planning and decision support to be tightly coupled to ERP, which our research shows that really reduces resiliency, and not all data that we need in planning or in decision support comes from ERP. So in the evolution of cognitive computing, we have to rethink the system of record and enable the processes to move from linear transaction flows to nonlinear flows, and to enable a new layer of decision support that can really be a system of record on its own. So the limitations that we had in the 1990s and the first evolution of planning are being challenged, and I think we need to challenge them as we test and learn. This is still very early, but it's evolving as we move from descriptive analytics, which allows us to just see data, see the relationships, and we get a lot of value out of just seeing data across disparate systems through tools like ClickView and Spotfire and Tableau, to predictive analytics, which are the traditional APS, revenue management, transportation planning. All of the planning systems are very predictive. They're linear optimization. They were based upon inputs. They have outputs, but we're answering the questions we know to ask. We're not asking the questions we don't know to ask. And the exceptions that come out, we're not giving any additional insight about what those exceptions mean. So as we move up the stack of analytics for insights, we move from descriptive analytics to predictive analytics to prescriptive analytics. And probably the best example we have of prescriptive analytics, which is not in supply chain, but is in our personal lives, is as we're driving down the road and we use maps. The maps not only tell us a way to get there, but they tell us alternate ways. And they not only tell us mileage, but they tell us time. And the time to get on a route is based upon what's happening on the conditions of the route. So perhaps there's road construction, or perhaps there's traffic. And so we actually are able to translate mileage into time through prescriptive analytics from things like Google Maps. So that is an example of prescriptive analytics, and we don't have much of that in supply chain today, to cognitive analytics, which allows us to sense, learn, and act. So this journey on insights from descriptive analytics, where I'm basically just visualizing data, to predictive analytics, which helps me to understand the most likely scenarios and the business implications, it doesn't really allow me to collaborate for maximum value or to understand exceptions, to cognitive analytics, which is highly automated, and systems learn and they get smarter over time. Today's supply chain systems don't get smarter over time. They actually will evolve in a negative way from the initial implementation. We'll basically put in hierarchies that we think are good, we'll test, but what happens is after those project teams go away, the business conditions change, perhaps people change, perhaps the answers or the data changes, and those systems don't learn, they don't evolve. And cognitive systems allow us to learn and evolve. So as we think about moving up the stack on the autonomous supply chain from predictive and prescriptive analytics to using unstructured data, text mining, perhaps it's quality data or warranty data or social sentiment data or call center data and pattern recognition on that data, to machine learning where I'm learning on the data structures, to cognitive computing where I'm sense learning and acting, we have the ability to change the rules of the supply chain. Our current rules are single ifs to single thens. These are things like ATP, allocation logic, inventory, and order matching. And these are single ifs to single thens. But if we can learn, then we can have multiple ifs to multiple thens. So perhaps we could have customer segmentation logic that's matching with inventory logic, or perhaps we could have learning systems for allocation based upon what's happening in the channel, or perhaps we could have adaptive manufacturing processes based upon what's happening in weather or heat or conditions. But the ability to have flexible rule sets and to evolve is really key in this next generational thinking for the digital supply chain. As we design value networks, we move outside in, we use multiple data forms, and we shift to sensing for the autonomous and localized processes. Now, to move in this direction, we must learn from the past to unlearn, to relearn. And one of the issues as we get started is most organizations want to pull the discussion into traditional models like SCORE and really focus on the efficient organizational silo. The cognitive computing processes allow us a whole new area to test and learn and evolve, where we can ask questions that we haven't been able to ask before, or redesign rule sets, or perhaps add sensors to be able to learn. And it allows us to get past transactional data and linear flows to be able to be nonlinear and use unstructured and structured data. And we can't just focus on process standardization because systems learn and we don't want to standardize them. We want them to learn and we want to transform the system so that we can have maximum value out of our cognitive responses to move to a traditional system. So we're going to now shift gears and let Ram talk a little bit about what Aera is doing, and then what I want to do is come back and share how to get started. So Ram, I'm excited to have Aera in the space to try to help people to test and learn with cognitive computing and drive some AI capabilities. Welcome to the webinar today.
Thank you, Laura. And what you just talked about in the past couple of slides is extremely fascinating for us, right? Just give me 1 second. I just need to show my screen. Is the screen coming through okay?
Yes, it's fine. Yes.
Thank you. Yeah, so Laura, what you talked about in the past couple of slides is extremely interesting, right? You talked about how we need to transform from inside out thinking to outside in thinking, outside in processes, designing siloed ERPs to more around value networks, accommodating multiple data forms. And then you talked about how we, supply chains of the past was designed from with act first and then think and learn later, as opposed to sensing and towards driving an intelligent response. And then you talked about how the linear process flows vis-a-vis a non-linear, much more accommodating process flows. You gave an example of Google Maps. These are all very fascinating examples. And from Aera's perspective, we see these literally as a C-suite agenda. Many of the large companies with complex manufacturing operations, they're looking for technology to enable their transformation. In fact, many companies are making this as part of a board agenda, for the next several years. And what is really driving this? This thinking has been there for now a good 5 years. They've been talking about digital transformation. But what's really driving today is that we have commodity compute power, we have data at scale, and we have innovations in Laura talked about RPA, robotics automation, NLP, virtual agents, and machine learning. All these things are fueling what was not possible before into an area of possibility, and the timing is just right. So at Aera, I'll spend just a couple of minutes introducing Aera and the company and the team, and then I really want to get into showing some product and sharing some customer examples that we are working with. So at Aera, we have assembled a team of leading industry experts that spans across ERP, analytics, supply chain, AI, and to fulfill what we call as the as a self-driving enterprise. Think of a moment. A self-driving car. We see these cars in Mount New office. We see both Waymo and Teslas here. But if you just imagine a self-driving car, it is connected. It's outside in. It's constantly sensing what's happening around it. It's constantly thinking. It's always on. It's real time. Even when the car is parked, it is, it doesn't stop thinking. The third thing it does is it is evaluating what to do next, right? It is making predictions. Should I turn left? Should I turn right? Should I reduce the speed? Should I increase the speed? And finally, it is able to make decisions fairly autonomously, right? The brain behind the car is able to take action. And the brain is, to Laura's point, is it's sensing, it's constantly learning, it's evaluating in context of what's happening in real time. And finally, once it decides, it can take specific action through deterministic flows. In the case of ERPs, you still need, the transactional flows, right? When you decide, you still need to manufacture, you still need to do your MRP and so on and so forth. So all those, deterministic flows are triggered by a decision which is taken within a context of what is happening in real time. If you just, step away from this notion of a car and really think about Aera. At Aera, we have solved that exactly for the for the extended enterprise. We have developed this notion of a cognitive operating system that constantly senses what's happening in your enterprise, makes recommendations, makes prediction, and finally acts into your transactional layer. And the way we achieve that is, what we call is a four-step process. First, Aera is able to continuously crawl your enterprise systems in real time and provide end-to-end visibility. Be it your ERPs, your WMS, your freight system, we are able to crawl across your extended enterprise. We're able to enrich that with any other third-party data that you might have. For example, we can augment and contextualize enterprise data with Google weather data. We could augment on time and full with integrating with freight and shipment data. So we provide that end-to-end visibility first, and once you have that visibility, Aera is able to make evaluate risks and opportunities in a specific business process and make recommendations. Right? These recommendations are both descriptive as well as prescriptive. Right? Because we are able to leverage artificial intelligence within the process context, we are able to make very, very prescriptive recommendations as well. And finally, Aera can take action fairly autonomously. Again, it's a journey. Many of our customers are at the understand and recommend phase, but then there are a few customers who are moving into more on the autonomous acting side of the house as well. So this notion of understand, recommend, predict, and act is a virtuous cycle that accommodates several points that Lora touched upon. She talked about schema on read vis-a-vis schema on write, right? So all this is possible because of this this capability that we have built at Aera. So very quickly, I'll go through how some of the steps that our customers are taking to getting started with AI, and then I'll show within a context of a demo. So the first point is to identify a specific problem for you to target. If you're a CPG company, if you're a pharma, if you're manufacturing, if you're automotive, there are certain very, very natural use cases. What deep pain points that you can target. So this should be super specific. One of the popular use cases that we see is around demand planning, forecasting. That's a very, very easy and natural use case where AI can be readily applied. We also see a lot of activity around service level attainments, right? AI can be used to predict whether there will be a supply issue, whether there will be OTIF issue, will there be any customer SLA issue because of some production delays, so on and so forth. So because of the fidelity that AI can bring to the table, some of these problems are very, very suitable for AI. On the manufacturing side, machines can read sensorial data. Lora talked about IoT, and it's not just one technology, but a nexus of technologies that come together to solve these problems. In essence, since machines can see data with high fidelity, it can stitch that together and drive manufacturing performance improvements. there are use cases around, procurement automation. AI can automate what I call as low-grade procurement decisions fairly in an efficient form. So these are some of the use cases that we see in the industry. Lora, feel free to weigh in and share any other specific problems that you are seeing in your in your network where AI is being used. The second thing, yes, Lora.
So I think the use of structured and unstructured data for demand planning is one that I often see people working on. Schema on read for demand planning, because we've evolved hierarchies that don't fit the business. Maybe we've gone through mergers and acquisitions. Digital manufacturing, where we're sensing off of programmable logic controllers and sensors to be able to look at when does a piece of equipment need maintenance. Use of cognitive computing in the rule sets, whether it's available to promise, allocation, or order management. I think the problem is that we're limited by current thinking, and we've accepted the current paradigms, and it's really, I think, a chance for us to challenge those.
Yeah, no, I think you nailed the issue. I think there is this huge what we see as a technology exhaustion, right? People have tried, aggregating different tool sets, and they've been throwing at the problems. But again, it's a thinking issue. But we, fortunately, we see because of a lot of business trends, right? The geopolitical volatility, the evaporating barriers to entry, availability of alternate form of capital. These things have fundamentally changed businesses' time frame for digital transformation. I think that is something that we are seeing, coming from the C-suite. So there is more acceptance and more what do you call it? More interest in trying out these things, Lora. It's very refreshing to see that companies have relegated the traditional ERPs into the transactional world, and they've started embracing this notion of cognitive automation. Just to extend Lora's point about, let's say, demand forecasting, that leads into my next point about AI readiness, right? If you take that forecasting as a specific problem to solve, let's say you have data with daily granularity for thousands of SKUs for 6 years. You might think that this is a huge data set. But if you consider it from an AI machine learning perspective, it is actually not a huge data set. Let us say you're forecasting for a single SKU out of those 1,000 SKUs. You only have 6 data points, for 6 years. If you take 23rd April, April 25th for 6 years, you only have 6 data points. And then if you augment that with some seasonality and some other features around that, you probably have 18 data points. So for AI to work, you really need to prepare the data, right? Things like selection, cleansing, scaling, decomposing, aggregating. All this need to be done, and then you need to consider what other data sets you can add to enrich. Lora talked about WMS. We talked about Google weather data. There could be additional data sets that probably runs on a different clock set. Like, for example, your POS data might be running on a different clock compared to your store inventory data, right? Or your warehouse data. You need to bring those data sets, and fortunately with AI, you can fairly efficiently synchronize these different clock speed of data to build a meaningful data frame. And then you need to be able to use the output of machine learning, output of AI, output of data science in such a way that it can be operationalized. This is something we see, several of our customers struggle when they use out-of-the-box systems like Azure and Amazon and Google, right? There are algorithms, there are compute, but then how do you put together a recipe and make it meaningful for your business? I call this as operationalizing data science. One way to do that is for machines to generate forecasts, in this case, for different time horizons simultaneously. So demand for a SKU at a store could be on a day, 1 week, or 1 month out. Similarly, demand for a SKU in a DC could be intraday. So the machine learning algorithm could be used to generate different time frame using different form of ensembling, and then send these forecasts to multiple stakeholders. The fundamental point I'm making is that there is more you need to consider in terms of readiness in a holistic fashion. Otherwise, people will lose faith in data science or an AI project, and it'll become a science project. And then lastly, once you decide on a couple of specific use cases, once you have a good readiness in terms of AI, you need to think about how to collaborate both internally as well as externally. Lora and I talked about how you need to have a trailblazer. It's not just a champion you need a visionary, you need a trailblazer. You need someone who can challenge current assumptions, challenge current thinking, and who's willing to embrace surprises, right? Any AI project will give you some surprises. It's going to fundamentally change the way you think and operate, because rules are not driving these things, but patterns and sensing drives these things. So you definitely need to carefully consider how to collaborate and build your team internally, but also partner with leading firms externally as well. Who are your technology providers that can help you target a specific problem, operationalize AI, and be your partner in that journey. So with that, I'm gonna please feel free to add in, Lora, while I'm preparing the demo systems here.
Yeah, so Ron, we have a question, and I love questions, so please put them in the chat box.
Yes.
The question is, how do you see organizations addressing these next generation processes? Does it make sense to be specific at a process and problem at a time, or build a platform incrementally, or go for big bang? And I'm going to start the answer, and then I'm going to let you, Ron, as you set up your demo. What I see is it depends upon the culture and the trust level and the ability for the culture to really do innovation sprints. I work with some clients that really want to reinvent themselves, and they've got teams of people that are challenged to reinvent themselves. And as part of that agreement for that reinvention, people will know that they're going to fail and that they're going to be rewarded for failure because they're going to fail forward. If you're working in a culture where this new technology perhaps is risky to your career, or you don't have that same understanding, you're going to want to work incrementally. You're going to want to be able to work in an area where you've got leadership trust, and you're going to have to get agreement that you're going to work incrementally. But if you have the ability to work on digital sprints and reinvent yourself, then you should innovate at the edge and bring it back to the core. Ram, your thoughts?
Yes, first thing is I agree, innovating on the edge and bringing to the core. I think that's the agile approach, and building on getting small wins and small success first, and rolling out to different theaters, different regions, and different parts of the business helps. And Lora, that is something we also see with our clients, right? They typically attack a specific business process. For example, your APO, they might be using APO for rough cut capacity planning, and then production scheduling. But then they might do what you highlighted as a traditional planning outside an APO or an APS context, right? And there could be a lot of painful manual efforts around that area, and maybe that's the area that folks might target. So I think identifying a specific process around the on the edge, and then bringing in once success is built into the core area helps. The second thing I want to reiterate is the importance of what Lora talked about, having the right data architecture, right? We saw the pendulum shift between IT and business to IT and so on and so forth. But now, Lora, what we are seeing in the industry is that there is really a very good collaboration between between IT and the business. IT is extremely how do I put it? Extremely collaborative and understanding of business, even more so these days. So almost all the discussions we are having involves IT eventually, either earlier or later. So having the right data architecture, at least the data thinking is a it's a multi-year journey, and having that is super crucial as you embrace these innovations.
So very quickly, questions, but let's go ahead with the demo, and then we'll get to the questions.
Okay, Laura, thanks. I'll keep this short. So, what you're seeing here is, a welcome screen. It's kind of the landing page for Aera. Just to orient yourself, you can interact with Aera in three different forms. One is you can directly interrogate the data, go directly to the data layer, ask questions, get recommendations, so on and so forth, very dynamically. The second way is if you're a functional user, like for example, if you want end-to-end visibility on your supply chain, understand service losses, and take specific actions, you can log into your specific functional area. So in this case, I'm trying to understand what's happening in my supply chain, right, all the way from purchasing through to production, through distribution to customers, and then I want to understand some root cause analysis around my service loss. So you can access Aera through this set of cognitive applications which we call as skills. And then lastly, more interestingly, as customers mature in their thinking, this is when this notion of augmented decision making or augmented driving comes into place. So in this case, Aera is making very descriptive recommendation on what to do. So in the specific example, Aera is telling you to increase production of a particular product to address a back order situation. So in this case, it is saying increase utilization at a Sao Paulo plant to produce 4,500 units of a product to avoid 57% of calculated back order. I mean, if you look at this recommendation, it is very, very prescriptive. It's almost that the machine has understood what's happening in the business. It has performed a lot of analytic function, and then it is telling you a very, very precise recommendation. Whenever a machine makes a recommendation, we need to be able to explain why the machine is making this recommendation. So in this case, it is, the recommendation consists of two parts, right? The first part is it is predicting a back order situation. The second part is it is saying that there is capacity. You can address part of the backlog using production. So for us to understand that, Aera is telling you what the predicted vis-a-vis the customer forecast is. So in this case, if I just uncheck some of these, I need to restart the demo. Give me 1 second. I hate when Chrome does that. But this also tells you that I'm live on the system. What's fun in demo if it doesn't? Yep. Okay. Got it back. So in this case, the system is telling you what the forecast is. So here I have the client forecast, which is fairly, there's a little bit of seasonality. It's fairly flat, but then, there's a little bit of a pickup starting June, July of 2018. And then the actual demand, based on the actuals that's coming in, I have a look at it 3 months ahead, but then after that, as orders come in, this will get populated. In parallel, what Aera is doing is, the machine is driving forecast as well. It is fairly in agreement with what the consensus forecast is, but then, right around May, June timeframe, there's a little bit of a pickup that Aera is predicting. And it could be due to several reasons, right? It could be because of some potential spot buys that are happening and spot bookings that are happening in some region. It could be because of some competitive stockouts. It could be because of some other third-party data, some other trends, some other signals that the machine is able to pick up because we are having multiple data sets in the system. Very quickly, and this is important. See, what we are able to do is we are able to ensemble close to a couple of dozen algorithms here. So in this case, the forecast is driven by traditional statistical methods like moving averages, regressive moving averages, so on and so forth. But it also combines certain machine learning logic like gradient boosting, Holt filters, multiplicative, random forest, so on and so forth. And the set of algorithms that will be used for this particular use case, for this particular forecasting depends on the specific use case. So in the case of forecasting, it could be 20 of these algorithms, but if you're doing a classification problem, like for example, if you want to predict anomalies, if you want to do predictive maintenance, it could be completely different sets of algorithms. So we are able to match a set of machine learning tasks to set of use cases and then develop some sort of a lineage behind this model. In any case, so in this case, the autoregressive moving average is producing the best fit, and the best fit is decided by the average bias error. So it could be, depending again on the use case, it could be the MAPE or some other metric. And then you're also able to see how these algorithms are predicting over a period of time across the product line. So you could see that random forest is predicting, for around 38 for 38 products fairly accurately compared to some other methods. So based on this prediction, we are able to pick up a forecasted back orders. And once I have the forecast back orders, I can, I know my inventory on hand. I know what the consensus is, what the predictive is. I can do a difference and I can say, okay, there is a potential back order of 8,000 units. I know the average revenue per unit. Then I can compute the exposure in terms of revenue. So the second thing we need to understand is, okay, I have a back order. I talked about the horizons, right? Do I have capacity to produce? Or is there should I ship inventory from one location to another location? Because, with Aera, we're able to see what exactly is happening in the business. We can understand what the current utilization or in a specific plant. We can understand what the average production time is, and then we can say, okay, by increasing utilization to a certain percentage within the time frame you need, you can build additional units. So in this case, that understanding is driven by what we call as end-to-end cycle time maps. What you see here is for that product, from some raw material to semi-finished to shipment to regions, you're able to see what the planned cycle time is, but also what the actuals are. So in this case, from a receipt to sales perspective, you can see the quality time planned vis-a-vis actual, release to sales planned vis-a-vis actual, so on and so forth. So you get this very, very granular visibility of planned vis-a-vis actuals, and then that helps you drive a decision on whether this can be manufactured or not. So, typically you don't want to directly create an order. This is a demo, but you might create a planned order or you might create an internal transfer order. But for a demo purposes, we are just creating a planned order. Once you create a planned order, depending on now we come into the deterministic workflow, right? Depending on what you want to do, you might notify head of planning, head of manufacturing. You might update some systems, and once the order is updated, the machine understands that some actions has been taken. It tracks the impact of that order, and finally, we are able to tie a business impact to the decision that was made with the help of a machine learning algorithm, and then drive continuous improvement. So this is again a very, very short example, but the point being, we spoke about targeting a specific problem. We spoke about how to assess AI readiness, and then we spoke about how to collaborate both internally and externally. Hope that that demo helped you, kind of understand how we do that in Aera. And some of the learnings from our from the customers that I've interacted with in the past 9 months at Aera is, again to Lora's point, have a right data architecture. Think holistically when it comes to data. Processes can be linear, but data typically doesn't lie. Of course, once you get the data into a single data layer. In Aera, we call this as a cognitive data layer, but develop that real-time state of the business. Without having visibility, you cannot make prediction. So I strongly encourage to develop that, this notion of a cognitive data layer. Second thing is, all projects should embed a combination of domain expertise, functional expertise, algorithmic expertise, and systems expertise. If you don't have systems expertise, but if you have strong just algorithmic expertise, you're not going to be able to make a business impact. If you miss out the functional knowledge, you're not going to be able to leverage the algorithm. So make sure the expertise is embedded. And lastly, make sure you can orchestrate this, right? Lora talked about schema on reach. She talked about nonlinear processes. She talked about shift from acting and learning to sensing and driving intelligent response. So those are all very important points. So think about how you orchestrate, and this is something we see directly from our customers. So with that, Lora, let me pause and hand back the control to you.
Okay. Well, thank you very much, Ram. We've got some questions. One question is, what skill levels are needed? And I tell people that you need the natural curious. They need the people that are able to think differently, the nonlinear thinkers, to be able to really challenge the current processes. System thinking, the people that, understand that they've got problems. So I encourage people to start with drawing, the last year on a whiteboard and looking at where you had issues, and then taking the areas where you had issues and then saying, how do you use these new techniques to really drive improvement? And that helps you, I think, to really drive the next steps for, how you move forward. Aera is a technology, targets a specific area, think about the data, the orchestration, the expertise. In a webinar we recently did with Merck, where Merck is an Aera client, what they did was they started to rethink visibility. They were using visibility very much transactionally, but they said, how can I use the cognitive computing along with cloud to be able to go across systems, to be able to get not only structured but unstructured data and data that streams, to be able to look at sensing, learning, and acting, and to be able to do that at the speed of business. So that's a good reference for you to think about visibility differently. The other thing is thinking about planning differently. One question that people had was, how do I think about SAP or ERP and planning? The traditional planning systems were linear optimization based upon inputs from transactional systems or clients, shipments, orders, and the output was time-based forecasting. So perhaps you use cognitive computing for machine learning on planning master data. Most companies do not really focus enough on planning master data, and this is an area that you could build and be able to use the cognitive engine to look at things like, how long does it take you to get from point A to point B, and how does that vary by time of the year, and how long does it take to perhaps unload in Long Beach, and how does that tie, and is there a way that we could maybe use a different sensor about unloading in Long Beach? Perhaps it's a picture of what's happening on the water, or perhaps it's drayage signals. So machine learning on data for the input, and then cognitive computing can overlay on top of things like SAP APO or Oracle systems to be able to sense, learn, and act, and to be able to do it differently. And maybe you take small steps. Maybe you do demand planning for something that's hard to forecast, like new product launch or trade promotions or display packs, or maybe you test and learn and market. But the goal is that you continually test, learn, and evolve. And you do that through innovation at the edge to be able to drive it to the core. And these demand flows that we talked about, need to be seen as the river of demand, just not a functional demand, to be able to look at, how can you sense, learn, and act if you start with demand, drive outcomes, and then be able to redefine planning. So I'm just going to wrap up here. First thing you want to do is start with the goal in mind. I like mapping the prior year and looking for opportunities. If you could have sensed, if you could have used a different data structure, if you could have learned, what would you have been able to prevent the business? And then use that as a goal. Never start this as a technology project. And then really adopt technology based upon your level of risk aversion. How willing is your organization for you to fail? Are they going to embrace your failure and fail forward and celebrate the fact that that's learning? Or are they going to be looking for a definitive ROI and they're going to want assurance of success? If it's the definitive ROI and assurance of success, start small. Make sure you're in your risk zone. But encourage people to learn from others. We've got about 7% of companies that are aggressively going after cognitive computing to transform processes. Educate, educate, educate. And then if you're able to innovate in a big way, innovate at the edge with the process and then bring it to the core. I like to tell companies to use stage gate processes to basically have a governance model that says, perhaps we were going to redefine ATP, or we're going to redefine order management, or we're going to redefine forecasting, or we're going to redefine digital manufacturing. Whatever that process is, that you go through stage gates so that you can say, I have met that goal at the edge, perhaps it's a factory or a part of the business, and now I'm ready to drive it to the core. And when you drive it to the core, you're going to overlay it on top of operational systems like ERP or SAP APO for planning, or perhaps other planning systems like JDA or Logility. Use those systems then as the system of record and basically allow cognitive computing to replace existing engines. And the best teams are small, scrappy teams. They're not people that, are seasoned supply chain professionals that believe that we have best practices. They're the people who are naturally curious, system thinkers, and they come from different parts of the business, and they're always the people that are saying, why not, let's do more. They're the people that like unstructured data, like gray areas, like embracing the unknown, and they are naturally curious. And they want to challenge their traditional paradigms, and then give them the environment to do that, right? Don't say, we've got best practices, really begin to test small, learn, and evolve. And remember, to be able to do this, start with the goal in mind, learn from the past to unlearn, and then challenge yourself to relearn and redefine supply chain processes. So that's our message today. Embrace new technologies at the right time. Match your technology adoption with your cultural DNA. Build capabilities with the goal in mind. And don't forget to manage the supply chain as a complex system. In the 1990s, when we were designing systems, we could only design linear optimization. Our computing power did not allow us to do some of the things we have today. So part of what we've got to do is really embrace the fact that ERP, APS type of capabilities are really going to become obsolete in legacy, and you can drive differentiation by taking a different path. Ram, thanks very much. I think we've got all the questions. Anything you want to say to wrap up?
No, it's a good wrap up, Lora. I think you said it all.
Okay, and we will make these slides available, and we encourage you to share the slides and really question if it's time for you to take a different path. Thank you very much, Kathy. Thanks, Ram. Have a good day.
Thanks, everyone. Thanks, Lora.